All right, so we already know about vertical angles, right? What do you know about all vertical angles? Okay. And we're going to learn some relationships about other angle pairs that are also either congruent or maybe add to 180. Anybody know what that's called if two angles add to 180? The word starts with an S. The angles are supplementary. Does that sound familiar? Okay. Out there. Let me, before we get cranking on what they do here, give you, and it's over, you won't have to copy this down on the notes page. Let's go to that notes page. As I try to, it's going to be a lot, I'll put it in there ahead of time. There, what? Where'd it go? Well, where, oh, there it is, okay, yeah. So, some point in your life, you learn that supplementary angles add to what? 180 degrees. And there's also complementary angles. Everybody ever hear of that term? Complementary angles, they add to 90 degrees. Okay? Now, let's say I have two angles here that match up like this and form a straight line, right? We call these linear pair angles. Well, linear, the base word of linear is what? Line. How many degrees in a line? Like if you thought of it as an angle. 180. So if we have a linear pair of angles, like angles 1 and 2 here, they form a straight line and they're supplementary, right? So measure of angle 1 plus measure of angle 2 equals 180 degrees. Okay? So linear pair angles add 180 degrees. Now, if we have more than a pair of them that do that, we can't really call them a linear pair because in this case, how many are there? 3 of them, right? So what we do is we call these angles of a straight angle, right? A straight angle is a 180-degree angle, a line. So angles of a straight angle add to 180 degrees. So in this case, angle 1 plus angle 2 plus angle 3 equals 180 degrees, all right? Now, here's a little property that will help us with some proofs, okay? And by the way, all this stuff we learn here, any definition of certain angles and whatnot will be reasons and proofs as you're finding out, okay? We have this thing called the transitive property, okay? And it applies to anything. When I define it here, I'm just using A and B and C, okay? So if I tell you, if A equals B, and then in turn B equals C, then A must equal what? Right? Do you see how it's transitive? So if A equals B, then B equals A, then we can translate A over here to being equal to C, right? And that goes for congruencies too, right? If A is congruent to B and B congruent, right? That makes sense? Or even parallel, right? If line M is parallel to N, and line N is parallel to line P, right? Then M must be parallel to P, okay? Now, it's a lot like substitution, because you guys see that? And they're almost interchangeable. Do you see how this would be substitution, maybe? Because if two things are equal, can't you substitute them for each other? Right? You've done that in algebra. So if A equals B and B equals C, right? Then can I take this B here and replace it with what? It's equal to it, right? All right, but if you think of it in this sense, we call it transitivity. And when you're using it as a reason of proof, it's almost interchangeable, substitution and transitivity, but certain things will feel more like transitivity, and you want to use that as a reason, okay? You'll see stuff, okay? All right, so now let's talk about two lines that are intersected by a third line, okay? And we call that a transversal. So you see these two lines here and here, right? And they're intersected by that other line. That other line is called a transversal. And we get a whole bunch of angles that are formed in there, don't we? Okay? How many angles do we end up getting? 8 of them. Now, as pairs, and by the way, notice I have arranged this so these two lines, for the moment, are not parallel. Okay? Later on, we're going to talk about when they are parallel. Right now, they're not parallel. And we have some angle pairs and names for these angle pairs that you will have to know. You'll have to memorize them, okay? They won't be on any reference sheet. They're very important. They'll be used throughout the course, okay? So, some angle pairs. So first here, alternate interior angles. Now, when you see the word alternate, okay, pay attention. It means two angles on either side of the transversal, okay? They're on opposite sides of this transversal. And when you see interior, it means they're in between the two lines, okay? Well, what about angles that are outside the two lines? It would be exterior, right? Okay? So alternate interior angles. So do you see angle 3 here? Nobody sees it? Do you see angle 3? Okay. And what would its alternate interior angle pair be? Partner be? 6, right? So 3 and 6, and what's another alternate interior pair of angles? 4 and 5, right? They're on either side of the transversal, different sides, and inside, interior, okay? Alternate exterior, all right? So look at here. 1 and 8, see they're on opposite sides of the transversal, alternate, and 2 and 7. Good, good, good. Okay. Now, corresponding angles. Remember when we did, say, like translations, right? And if it was an angle over here and he slid it, it's corresponding with the other angle over here after we translated, right? Okay? So corresponding angles kind of match up to each other if we think of maybe translating one of these lines down to the other, right? So angle 3 would correspond if we did a translation to angle what? 7. Get the idea, right? How about angle 2? What would that translate to? 6, right? You get what I mean? Angle 1 would be corresponding with what? 5. And then 4 would correspond with 8. You get the idea? So those are corresponding angles if you think of it as a translation. Because in translation, we talk about corresponding angles, right? Okay? Now, consecutive interior. Well, you know the interior part, right? Okay? So these are not alternate. Consecutive means what? One right after the other? Okay? So consecutive means they're on the same side of the transversal. And sometimes you'll see them called same side interior, but that sounds too kindergarten-y. Ain't that? Let's plus the numbers together. Anyway, let's grow up, right? Yeah. Consecutive interior would be like angles 4 and 6, right? They're both interior on the same side of the transversal. Consecutive. What other angles would be consecutive interior? 3 and 5, okay? Now consecutive exterior. Now we're going outside the lines. So it would be angles 1 and what? 1 and 7, and 2 and 8. Okay, so those are the angle pairs and the names. You got to know about them. Okay, you got to have these committed to memory. We'll do enough of them. You know, it'll start to seep in. But there are many things in this book that you need to commit to memory. And by the way, at this level, right, there are so many things that we need to keep in our brains, especially if we're doing proofs. You've gotten a whole lot of information from the beginning of this book all the way till now, right? Some of that information tends to leave your heads. I don't remember mentioning this to you last week or not. What you should be doing as students at this level on this advanced path, right, is every now and then, spend 10 minutes a day, go back through your book, right, just start flipping through and reacquainting yourself with some of the ideas, right, especially like some of the note pages I give you, where I talk about midpoints and segment bisectors and different theorems and stuff like that, okay? You should be, 5-10 minutes a day. Just, if you have to do anything rigorous, just go back and look through and just get some of these concepts in your head, because you will have to recall them and use them frequently, okay? Stuff we learned on day 1, it's not going away, right? We still use it, okay? All right, so that's that. So now let's go back. Remember, in this case, we're just naming the angle pairs. We're not talking about when these lines are parallel. I drew them intentionally non-parallel. So let's go back. Now, look at some of these angle pairs and how they relate. And way back here. Okay. I crossed this section out here, but like one way to prove, that vertical angles are congruent, right? I'll touch on this very quickly. So like angle 1 would be congruent to angle 3 here, right? Because they're vertical angles. Well, what? Can you think of a way to justify that through maybe like one of the transformations that we did? So what, is there a transformation that would map angle 1 onto angle 3? I'd say more like it, I'd say probably a rotation. I would need some other point to make a line to reflect in is the only problem there, all right? I'm not really worried about orientation because we don't have, you know, full figures here. So you could have reflection if there was some other point in a line we could define, but we don't have that. So we have a point we can rotate about, right? So can we say 180-degree rotation would map 1 onto 3, and also for 2 and 4, right? And if they map through a rigid motion like a rotation, then they are what? Okay, so I just always be thinking of things in terms of other things that we learn in a different way, right? So now we got down here. So let's take a look at where we can use the linear pair angles and the vertical angles, okay? Here's some situations. So they've given you these intersecting lines. Here's this angle's 34. They want us to find angle 1 and 2. Well, if this angle's 34, what's the measure of angle 1? Because they're congruent, right? Now, to find angle 2, these two are what angle pair? They form a line, so they'd be a linear pair, right? And what do you know about linear pairs? So measure of angle 2 would be 180 minus 34 because of, right? So 146. Get the idea? Now here's one where you have to set up an actual equation and solve it, right? Want us to find x. These are vertical angles, so what do you know about them? Congruent, right? Which means their measures are equal. And so in math, when two things are equal, what do we put in between them? An equal sign, which gives us an equation, right? So 2x plus 16 equals 124. You can solve that, right? Subtract 16 from both sides and divide both sides by 2, okay? So you'll have to do some problems where you set up an equation and solve it. Now how about over here? What would be our equation here to solve for x? Well, first of all, do they want us to find x? What do we need to find? So we'll need to find x and then do what with it? Plug it in, well, to one of the expressions, right? Okay. So the equation would be 5x minus 4, that angle, equals 3x plus 16, right? Subtract 3x from both sides, right? And then add 4 to both sides and get 2x equals 20. Now, here's what happens. A lot of kids get to this point, x equals 10. Ah, I'm done, man. I got x equals. You're not done. You got to do one more thing. Find FEG. Put the 10 in for the x and 5x minus 4, okay? So be careful when you see one like that. Don't get excited when you get x equals. It doesn't mean you're done, all right? All right, let's go over to the next page. And here's some examples for you to try. If they have some expressions here, I do want a proper equation set up, okay? With the proper work shown to solve it, you know, nice and vertically, okay? So I'm going to give you all a moment to work on 1 through 3 here on your own. So measure of angle 1 equals 180 minus 41, right? Which equals 139 degrees. We're good with that? They're a linear pair. Now, who is able to slog through and do all the work necessary to find angle 2? Let's measure of angle 2. Oh, is it that easy? Why is it 41? What do they call them?
Vertical angles.
Vertical angles. By the way, how do you know which is the first one?
The only one that's shown for one.
How do you know it's before? Maybe they put it there after.
It's the only angle that we degree that we know.
Oh, okay. Well, you said before. I just like chronologically. I didn't know how you know it got there first when they got there second.
See, we're picky in math about how we describe things, right?
That's the purpose of it.
Great in math, power to explain.
Yeah. Well, you'll have to find that power. Anybody get number 2? At least have an equation for number 2. What's the equation? Nobody got it yet? That shouldn't take long. Okay. Yes. Angle 2? They're vertical angles, and all vertical angles are congruent. Right? So that's 41, that's 41. Vertical angles congruent. Did you get number 2 here yet? Yeah. I couldn't hear you. For number 2, X is 84?
No. Well, I know it is.
Well.
82 divided by 30.
Maybe. What'd you get?
I got X equals 26.
Everybody agree with that? 26? All right. Subtracted 18 from both sides. What'd you get? 78 divided by 3. 26. Right? Give me a second on the last one. Now be careful. What do they want us to find on the last? Well, boy, they really spelled it out for us. Find X and measure of CAB. A lot of times, most of the time, they'll just say find a measure of angle CAB. Hang on. Thank you. Yes. Thank you. But we're not done when we get X. What do we need to do now? So CAB is this X plus 40. So the measure of angle CAB is going to be our 40 plus 40, and we get 80 degrees. Okay? All right, any questions on those? Okay. So now let's move. Before we were talking about those 2 lines with the transversal and all the angle pairs that are formed, right? And you got to know the names of those angle pairs. Okay? And before I was telling you the lines aren't parallel. Well, now we're going to consider the lines parallel, and that's going to give us a whole bunch of congruencies here. All right? But first, I think I remember telling you to think of it maybe as a translation, because after a translation, corresponding sides are always what? Side. Well, congruent, yes. But also what? As it slides from here to here. The sides will be what? What? Parallel. Right? And congruent. So parallel. When we do a translation, we get parallel segments, don't we? Okay? So let's put together our 2 lines cut by a transversal with a translation, right? So let's start with this line BC, okay? And translate it down with this vector here, right? So what happens when we translate it? We get these 2 corresponding angles to be congruent. Remember that is one of our angle pairs, see how it connects? And these lines are now also what? Parallel, right? So do we kind of have our 2 lines maybe starting to get cut with a transversal here? Right? But we're thinking of it as a translation, okay? So the important thing to know is that after a translation, right, corresponding segments are parallel, aren't they? So corresponding segments parallel, and corresponding angles are what? Angles are congruent. Okay? So we translate from here to here. These segments are parallel. Well, they're not even really segments, right? The lines are raised. But they're parallel, and these angles that correspond are congruent, right? We just move the angle as well. Okay? So now we end up with parallel lines, right? With a transversal. Okay? If we think of it as a translation. So now all those different angle pairs which we identified, right? Alternate interior angles, alternate exterior, consecutive interior, right? The whole lot of them. Now have certain known relationships. Okay? Some of the angle pairs will be congruent, and some of them will be supplementary. They'll add to 180. Okay? Let's go over to the next page here. The most obvious angle pair, remember one of our pairs were corresponding, which makes sense if you think of it as a translation, right? Corresponding angles, okay? So if we have parallel lines, so this always if the lines are parallel, right? let's think about translating this down here, right? Translation, okay? All corresponding angles will be what? Congruent. So, do you guys see if we translate this down, angle 3 will translate to what? We'll map onto what? 4. So angle 3 is congruent to angle 4. What will angle 1 map to? So those corresponding angles are congruent. How about 5? Right? And 7 goes with, so all those pairs are congruent to each other. So if the lines are parallel, the corresponding angles are congruent. Okay? We had some other angle pairs. We had alternate exterior angles, right? So like 7 and 4. So let's think about this for a minute. If the corresponding angles are congruent, right? We know that 3 and 4 are congruent, aren't they? Because they're corresponding. But is 7 congruent to 3?
Yeah.
Because they're vertical angles. And then 3 is congruent to 4, right? So then 7 must be congruent to, remember the property that we listed? What says that? If 7's congruent to 3 and 3 is congruent to 4, then 7's congruent to 4. Isn't that the transitive property? Remember that? Can't we just use transitivity here? Okay? So that tells us that alternate exterior angle, and that'll go for any of them, 5 and 4, right? So 7's congruent to 4. If the lines are parallel, alternate exterior angles are congruent. Right? Not necessarily have to remember why, but we use transitivity. We can use substitution too, right? Okay? So consecutive angle or corresponding angles are congruent. Alternate exterior angles are congruent. And they go on to discuss it a little bit more. I don't want to beat a dead horse. So let's move on to the next page. Okay, consecutive interior angles, or same side, I guess. Same side, okay, same side interior angle. So that would be like 1 and 8, 3 and 6, okay? Well, let's think about this for a second. You guys know that 7 is congruent to 8 because they're corresponding angles, right? But what about 7 and 1? What angle pair is that? They form a line. So they are a linear pair, which means that they, no, they add to 180. They're supplementary, right? Right? So if 7's congruent to 8, right, and 7 plus 1 adds to 180, what can you tell me about 7 and 8? Scratch, I mean 1 and 8. You started again, sorry. Okay, so 7 and 1 are supplementary, right? Okay, and 7 and 8 are congruent. So what can you tell me about 1 and 8? They're supplementary. So it's kind of like transitivity, a little twist, right? Right, not necessarily congruent, congruent, congruent. But it's like congruent to supplementary to supplement, but it's kind of the same thing, right? So consecutive interior angles, or same side interior angles, are supplementary. They add to 180, okay? There's one's on the inside and the same. What about 3 and 6? Will they add to 180? For the same reason. They're consecutive interiors, okay? Now let's look at consecutive exteriors. Consecutive, right? They're on the same side of the transversal, so like 7 and 2, right? Do you think that they're going to add to 180? For the same reason, right? 1 and 2 corresponding and they're congruent, right? But 1 and 7 are supplementary because they're a linear pair, right? So that means 7 and 2 are also supplementary through transitivity or even substitution, okay? So all the consecutive interior ones, or the same side, interior or exterior ones, are supplementary, right? So we have some congruent pairs and we have some supplementary pairs. And you are gonna, I know this is probably spinning around your head right now, but as we use them, they gotta be in your head, okay? This will definitely be one section to, as we go along, flip back through. And it's summarized fairly neat. I know this is kind of a met, like if you want to look back at something to see which pairs are which. If you take a look on the next page, that box up here, okay? This tells you which pairs are congruent. Corresponding angles. This is only when, if the lines are what? Parallel. They have to be parallel. If lines are parallel, then corresponding angles congruent, alternate interior, alternate exterior angles are congruent. If the lines are parallel, consecutive interior angles are what? And consecutive exterior are supplementary. They add to 180, okay? So let's right here, let's just get started and provide the name for the following angle pairs here. So angle 1 and 5, 1 and 5, what would we call those? Well, it can't be alternate because they're on the same side, right? Corresponding angles. Think of the translation, right? Corresponding angles. How about 2 and 7? Opposite side, so alternate on the exterior. Good. So we can abbreviate alt exterior T angles. Okay? How about 5 and 4?
Alternate interior.
There we go. Alt int, you can abbreviate if you like, T angles. And then 4 and 6? Not corresponding. Consecutive what?
Interior.
Consecutive interior angles, or same side interior. Okay? All right, for this next section here, we're going to find a measure of an angle and give a good reason for it. Now, these reasons you want to think about because we'll be using them for proofs. Now, each of our reasons here depends on the two lines being what? Parallel. So I'm going to start off. I don't want to write it every time because they didn't give us a whole lot of space. But each of these reasons we put here would, like in a proof, start with if lines parallel, comma, dot, dot, dot. Then the reason, okay? Because the only reason a pair of alternate interior angles would be congruent is if the lines are parallel, okay? All right, so measure of angle 1. Let's look at angle 1 here. Can we figure out what its measure? And by the way, now we've got parallel lines, and they've given us 2 transversals, right? So we'll have to maybe in our head, like, eliminate the one we're not thinking of, like, to think clearly about it. So angle 1, is there something there that could tell us the measure of angle 1? What?
180 minus 82.
Careful. Do these 2 add to 180? The 3 of them add to 180. Their angles are, so we don't have, we're missing that one. Give your hand up.
Yeah, remember.
Okay, never mind. Let's think of our angle pair. Yeah. Let's raise your hand. Why are you stretching? Why would it be 46 degrees? Yeah, if we think of this as a translation, they're corresponding angles, right? So angle 1 is going to be 46 degrees. Because if lines parallel, then corresponding angles are what? Congruent. Okay, hang it down. How about angle 2? Why would it be 82? Again, aren't they corresponding, right? Just using the other transversal now, right? So that would be 82 degrees, because if lines parallel, again, corresponding angles are congruent. And then angle 3.
46.
How do we know it's 40? Well, wait a minute. Don't angle 3 and 82 add up to 180? Aren't they a linear pair? Are they? No. Right, they don't quite make up the whole line there, right? Okay.
1 and 3 are vertical.
Okay. We're going after angle 3, right? Well, let's suppose we hadn't found angle 1. Is that what you're doing? I think you're right. You were going to say angle 3 is 46 because of that. Yeah. Let's presume that we don't know angle 1 right now. Let's use one of our angle pairs for parallel lines. So like 3 would be one of our angle pairs with what? And what would that angle pair be called? Alternate. And if the lines are parallel, what? Alternate, right? 3 and 46. They're alternate interior angles being congruent if lines are parallel. Okay? So you're going to need to know these angle pairs. All right, let's move down here where we have some equations we might want to set up. Or we need to set up. So down here. Now notice how these lines are marked. What are these markings here? Parallel, okay? Which means you know stuff about these angle pairs, okay? I'll work through the first one here with you. So solve for the unknown values. So we're not looking for angles, right? So we have this angle and this angle. What's that angle pair name? Alternate interior angles, right? And the lines are parallel, so what do you know about them? Congruent, which means they have equal measure. What's our equation? Okay, see, this isn't that hard. Once you know the angle pairs and how they go together, right, just set up your little baby equation from first grade, right? So add 4, we get 5x equals 50. What does x equal? 10. Good. All right, you guys move on to do B and C on your own, okay? Write a proper equation and solve it properly. See how mine looks? Circled at the end, nice and vertical. What's the angle pair here in B, by the way, guys? Which angle pair are these? Not the alternate, they can't be. They're on the same side, right? What consecutive?
Exterior.
Yeah, consecutive exterior. And what do you know about those angle pairs if the lines are parallel? They what? Add to 180. So what's the equation for this one? This thing and that thing add to 180. What's my equation?
20x plus 4 plus x plus 50 equals 180.
I know some of you probably wrote 2x or 20x. Whoops. Should be a 20 there. 20. Some of you may have written 20x plus 4 equals x plus 50. You see why now that's not the correct equation, right? Because we know that angle pair is supplementary if the lines are parallel. All right. Let's combine like terms, I guess. So we get 21x plus 54, right? So 21x equals, what's 180 minus 54? 126. Divide by 21, what does x equal, guys?
6.
Everybody agree? Okay, be careful. And what will happen a lot of times is, there'll be a supplementary pair of angles, and your reaction will be to write down the two things are equal and solve it. That's not right. C should be pretty easy. What's the angle pair? Alternate, what? Interior. What's our equation? Well, I couldn't hear. 4x. Because they're congruent if the lines are parallel, right? So what does x equal? Calculator your desk, right?
28.5.
48.5, right? Okay, point. Okay, so you got to know the angle pairs and how they relate if the lines are parallel. They're either going to be congruent or supplementary. And quick references, like right up here on this page, you get doing your problem set. Oh, I can't remember. It's right here. Right here's all congruent pairs. There's all the supplementary pairs. Then it probably, okay. Oh, well, wait a minute. Which ones are alternate interior? So then I would go. Well, I would go. I would say between this and this, right? So this will tell you which pair is what name, right? And then back to that table here, it'll tell you which ones are congruent, which are supplementary. So between the two of them, you probably want to refer back to both of those, okay? All right, let's talk about a slightly different thing then. Top of this page. This is important to know. So we might have another proof reason here in certain situations, okay? So points on a perpendicular bisector. Okay, remember what a perpendicular bisector is. What does it do to a segment? Well, because it's a bisector, what does it do? Into two congruent segments, right? And because it's perpendicular, what about it? It forms what? Right angles, okay? So perpendicular bisector is two things. One is perpendicular, making right angles. Two, it's a bisector, right? Making two congruent segments. So this is important. Points, any points, all points on a perpendicular bisector of a segment are equidistant from the segment's endpoints, okay? This is important to know. So here is a diagram. This thing here is a perpendicular bisector. Everybody agree? It's congruent right angles, okay? And what they did is they picked a point C on that perpendicular bisector and made a triangle out of it, right? Now, do you remember? We did some constructions a while back, right? And we were asked to construct a line of reflection. What was it that we actually constructed? They gave us like two reflected triangles. You just did the perpendicular bisector, didn't you? Right? So we could think of this equidistant business, as coming from what transformation? Which one? Reflection. Because we have a perpendicular bisector, and that's what the mirror is, right? That's that line of reflection. So that would mean that the distance from C to A, this endpoint, and C to B are what? Congruent. Right? So that point C is equidistant from the endpoints. Yes, sir?
AC and BC would have two congruent marks because A and B.
Yeah, well, that's what I said, right? You're saying AC and BC are congruent?
Yeah, but they have two congruent marks behind them, otherwise they're
Oh, the double. Yeah, I got you. Yeah, sorry. Right. Yeah, you're right. Thank you. Thank you. Yep. Good call. Well, let me ask you this. So C is equidistant from the endpoints A and B. What about this point? Is it also equidistant from the endpoints? For the same reason, right? Wouldn't that be the same? What about this point if I put it here? Will that be equidistant? Right? What if I go down here and put a point there on the perpendicular? Same, right? They're all going to be equidistant because we think of them as congruent coming from reflection, okay? So, and I'm not going to bother putting all the marks on that one because you're going to jump all over me. I don't want to put like 5 in there and make a big mess of it. But you get the idea, okay? All right? So in other words, we can say it's reflection, right? CB, wouldn't it map to CA? Right? I can write that down. CB maps to CA with a reflection, which is isometric. Makes things congruent, right? We're always connecting stuff back to what we learned, okay? Let me go on and talk about, I covered some of this, pairs of angles. Okay, adjacent angles. Do you remember the linear pair angles? Right? Linear pair angles also happen to be adjacent angles. They're just like right next to each other, right? So adjacent angles, they share a vertex and a ray. So like angle 1 and 2, wouldn't they be adjacent? And specifically, they're adjacent angles, and they're also, in this case, a linear pair, so they add to 180, right? But not all adjacent angles. So adjacent angles could look like this as well. Right? Those two are adjacent angles, right? but they're not necessarily a linear pair. See the difference there? So I don't want anybody thinking that all adjacent angles are supplementary. Only if they're like angles 3 and 4. They're adjacent, but they also form a line, so then they're supplementary, okay? So then we already talked about linear pair, add to 180. We already know about vertical angles. I love how they put that stuff after they talk about it, right? Smart. That's why I try to give you the no space. I always drive me nuts, okay? All right. Let's now take a look at, so we time doing 40 minutes here, the Regents questions. Handful of these, huh? And don't forget, guys, other things we've learned, like if you have a triangle, all three angles add to what? Huh? Right, we got to remember stuff like that, okay? All right, so read this over, remembering things that you've learned. Does it say, hey, does it say we have parallel lines here? It doesn't? Right, we got to read it all, right? Yeah. Yeah, they could have just called it A, B, and C, D. That's kind of goofy that they did that, but whatever, okay? Yeah. So does this look like parallel lines with a transversal? Oh, hey, but there's another transversal, right? Okay. Well, okay, thinking of it that way, I'll get rid of those so they don't get too messy. So let's put in that we got EFG. EFG is 32 degrees. And AEG is 137, so that's 137 degrees. They want the measure of angle EGF. I'm going to put an X right there, okay?
What are the 4 chickens?
I'd mark with an X to keep it simple.
Can you do 180 minus 137 to get the angle of DEF?
Oh, we could find this angle here, right? Because these are what kind of angle pairs? Linear pair, right? So I could find, so then, well, so what if I find this angle here? How does that help me find this angle? What's this shape, guys?
Triangle.
Triangle. They add to what? Okay, so let's do 180 minus 137. What do we get? What?
43.
43. So this is 43 degrees. Okay. So now what?
Subtract it by 180 subtract both of those.
Yeah, subtract both those, so we can do x equals 180 minus 43 minus 32, right? So what do we get for that? 105, right? So you see, we have to be able to recognize, I know sometimes I think you're used to, when you get a math problem, it's only going to use the stuff that you just learned, right? But, you know, you learned triangles, angles at a 180 a long time ago, and we're using it, okay? Is there another thing we possibly could have done using what we learned today? Like, if that's 43, what's the measure of this angle down here? Because they're alternate interior angles, right? So I'll do this substitute, right? And if that's 32, these lines are parallel. If that's 32, what's this angle down here? 32 degrees, right? So what, these are angles of a straight angle. What do they add to? So couldn't I just do 180 minus 43 minus 32 to get that? Isn't that what we just did? So you see how we look at stuff from 2 or 3 different angles and reconcile it, right? So we looked at it using the triangle, and we also looked at it using the parallel lines and transversals and angles of a straight angle, okay? So you got to be able to, be flexible. You got to be able to see it from many different angles, sides, I should say, or aspects, angles and sides, right? Okay. Did we talk? We didn't talk about the exterior angle thing, did we? We'll get to that a little later. All right, never mind. I won't blow your brain holes with that. Okay, move on to number 2. Oh, and by the way, again, before we get to this, we said, we went over those angle pairs, right? And we said that if lines parallel, then, for example, alternate interior angles congruent, etc. Remember, in math, what else is true? The converse of every conditional statement, right? So what would be the converse of if lines parallel, then corresponding angles congruent? If corresponding angles congruent, then you can say the lines are parallel, right? That's kind of what they're doing here. They're working the converse a little bit. So read that over. What do you guys think? Which lines have to be parallel here? Choice 2, L parallel to P. Why?
Those two angles are the ones that have to and they're corresponding.
112 and 68 are not corresponding. If we were to think of these as lines with a transversal, what would these be? Consecutive, exterior, and they would need to add to 180 to make the lines. Do they? Right? So we verified that, right? Another way, here's another way we could do it. What if we, so we know that's 68, right? What's the measure of this angle here? 112, what? Minus, or one, I'm sorry, 180 minus 112 is what? Right, linear pair, 180 minus 112 equals 68 degrees. Now these are corresponding angles being congruent, right? So lines are parallel. I mean, you could go all over the place with this one. Right? Probably find alternate, interior, and exterior, whatever. Okay? All right, so many ways to skin a badger there. We have one more? Or two? One? All right, one more. Now we got to go back to triangles congruent. And listen, some of our ways to prove triangles congruent include not only sides, but congruent angle pairs, right? Do we now have another way to find congruent angles? We just learned it, the parallel lines and transversals, right? Okay, so this will make the triangle congruency so much more exciting. All right, so read this over then. By the way, before we apply any of this stuff and put it in the diagram, from this diagram, is there something in there that's always going to be congruent, no matter whether they give it to you or not? Nothing? Yeah, right? Vertical angles are always congruent, right? So we can start with that and then apply the other thing to see if it works. What do we think? 3. So if we say E is the midpoint of AC, well, that would make that congruent and that congruent, right? Is that enough to get the triangles congruent? We've got angle and side. Well, wait, maybe you're thinking these, does it make those congruent? No, it doesn't. Why not? It's only the midpoint of what? Yeah. Well, let's look at 4. Oh, now maybe we got something, right? BD and AC bisect each other, right? So BD and A, so that means these are congruent. Now we have that, don't we? It said bisect each other, okay? So now we have what? Side, angle, side. I want to look up here. How about number 1? Let me do this. Would number 1 get our triangles congruent? Parallel? Well, wouldn't that make, say, these angles congruent because they're what? If we make parallel lines cut by a transversal, those would be what angles? They're on either side of the transversal, so they're alternate interior. And, right, that would make them congruent. What about this transversal? Wouldn't these guys? Would that make the triangles congruent? Angle, angle, angle? It's not up there. Angle, angle, angle. So no. All right, you get the idea? Okay? All right.